So hi. So in this video we can discuss about the inherited attributes. Okay. So here in inherited attributes means the values for the inherited attributes will be computed from the values of the parent or from the sibling nodes. Okay. For synthesized attribute, the values of the attribute we got it from our child nodes. So in this case, we will get the attribute values from the parent or the sibling or from the sibling nodes. Okay, for if we are considering an example, that is a production that is A gives B, C, D. Okay, so here we have an inherited attribute IN for the variable C. Okay, so C dot in is equal to A dot in. That is A is the parent node for this particular non-terminal C. Okay, and the second is a C dot type. So type is an inherited attribute. So here also we will get the value from the sibling of C, that is B dot type. That is C dot type is equal to B dot type. So this is how we will get the values. Okay. So again, there is one more rule is there. We will get the value. Suppose we are finding out the value for C, right? So we have to take the non-terminal. We will get the value only from the non-terminals, or only from the symbols to the left of the productions. We will get the value of to a symbol only from the left of the symbols. That means that suppose we have a production. Okay, so here we have a production, say A, sorry, capital A gives uh, so I'm writing some symbols. Okay, GHI. Okay, so here if we want to derive an inherited attribute for J, I can take only, I can derive that value, or I can have that value only from G and H. Okay, that is the symbols towards the left side of this variable. Okay, I can't take the value from the K. Okay, that is the rule that has to be applied for inherited attribute. Okay, so for example, I can give you another example. That is, if I have a production that is A gives QW. So A gives QW, then we can't take a production that is here. If I am having an inherited attribute, um, if I want to have an inherited attribute for Q, okay, so I am taking a inherited attribute for Q dot. So in order to specify it is inherited, the attribute is inherited, I am taking now type as I. Okay, so if Q dot I equal to, we can't give W dot any value. Okay, so the synthesis, so if I want a synthesis attribute or something like that, I am representing it as S. Okay, so here we can't take W dot S. Sorry, dot S, where S represents the synthesized attribute. Okay, this is not possible. If therefore we can take this as a particular inherited attribute. Okay, so here we need to consider this rule for creating the inherited attributes. Okay, so only we can take the values of the parent as well as the left side of the symbols. Okay. So here, how we can compute the computation of the inherited attributes. First, we need to construct a SDD. Okay, sorry, we have to construct a SDD using the semantic actions, and next we have to construct the annotated tree. Okay, by using a top-down manner. So here, inherited attributes in the case of this, with the parse tree, the annotated parse tree is constructed in the top down, whereas in synthesized attributes, the tree was constructed in a bottom up manner. Okay, so now we can see an example. Mm, so here we can consider the following grammar, that is S gives TL, T gives int, T gives float, T gives double, L gives L1, ID and L gives ID. So this is nothing, it is a grammar for a declaration statement. Okay, that is int A comma B or something like that. A comma C or A comma C, B comma C. So this is a grammar for a declaration statement. Okay, so I am having the data types int, float, and double. Okay. So next I am writing the SDD. That is this is the specific definition. Okay, syntax declaration. So here this is the definition. SDD, the syntax directed definition. So here the given production is given here, and as well as the semantic action that has to be performed for each production is given here. For each production, we have to perform this action. Okay. For if you, when we consider this production, that is S gives TL. We are having two non-terminals T and L. Okay, and here the if I am having a production, this production, if my tree is reduced to this production, then I have to perform this action, that is L dot in is equal to T dot type. That means that I am having a attribute in and a attribute type. Okay, so here the L for the variable for the non-terminal L dot in, I can assign the value of T dot type. Okay, so again next is T dot type. For this production, I am having the action. My semantic action performed here is, that is I am copying the that is a keyword, int keyword is copied to T dot type. Similarly, the float value is copied to T dot type, as well as the double. It is in for this type of declaration, I can have an integer variable, floating point, as well as a double. Okay, so these are the keywords. Again, next one is I am having a production, that is L gives L1 comma ID. So L1 is nothing, the same L itself. So in order to differentiate the left hand side L and the right hand side L, I am simply giving a 1 here. Okay, so here this left hand side L1 dot in means it is a inherited attribute. We can say it is a in is a inherited attribute. Okay, so why it is inherited attribute? When we create the syntax tree or the parse tree, we can see why it is called as inherited. Okay, so this value, so here L1 dot in will get the value from L dot in. Okay, so we will be having a function, so we can add a type for this id dot entry. So here this is a function, enter underscore type is a function. So we by using this function, we can add the data type of the variable that is in L dot in. So whatever it is in L dot in, okay, so that, oh sorry, whatever the data type that is given in L dot in, okay, so that data type will be added to the identifier's place, which is in the symbol table entry. Okay, suppose for if you are considering an example, if suppose id dot entry is having a variable named sum. Okay, so in the symbol table we will be having a particular row for sum, right? So for that sum, for that particular entry in the symbol table, so if the value of L dot in is int or float, suppose I'm taking as it as int, okay. So then in the symbol table entry, this integer int data type will get added to the entry sum in the symbol table. So that is the function that is doing here in this. When if we are having this production, that action will be performed. Whatever we get a data type, okay, that data type will be added to the variable, is in the place of id, okay, in the symbol table. Okay, so next when we get an id, just the again we will be having a data type in L dot in. That particular data type will be added to the variable or ID entry in the symbol table. Okay. So these are the actions that are performed if this production is reduced in a parse tree. Okay. So we are generating the annotated parse tree. So here in a semantic analysis, the output will be a annotated parse tree, right? So here I am assuming that I am giving an input string that is int a comma c. Okay. So here in order to compute the inherited attributes, okay. So here I am considering a input string a comma c. Okay. So here, so this is the tree that is annotated tree that is generated for the string int a comma c. So first we can see that is here uh, we can see the STD also parallelly. Okay, so here this is the semantic actions for our productions. Okay. So first this is the annotated parse string. So I will explain in detail. That is first anyway initially we are having a okay. So first I'm taking this production that is S gives TL, right? So here this is the production that is S gives T and L. So first we will be having a root node that is S. Okay. So if we can expand this node that is by T and N. Okay. So here T will be there and again L will be there. So initially we will be having a parse tree. So here anyway first initially T will be having no values. Okay. So again I am having a what is it? I am taking the production that is second production that is T gives int I am taking. Okay. Therefore, int will be the leaf node here. So now I got a value for T dot type, right? Now the value of T dot type is equal to int. Okay. So here now the value of T dot type is int. Okay. So next I'm going to the other side of the tree. That is what is L dot in. So now I have no value for L dot in, but when I reduce the production, that is how I can get L dot in. So the semantic action of L dot in is T dot type, right? So here T dot type. Here also we can see that L dot in. For L dot in is a inherited attribute, right? So here we have taken the term non-terminal that is left to this particular symbol L. So T is situated at the left of the non-terminal L. Okay, so here we got a value L dot, for L dot n, the value from this particular attribute, that is T from the type attribute. Okay, so here this is a synthesis attribute because this T dot type got a value from the child node, right? This is a child node for this attribute. So we can say that this is a synthesis attribute. Type is a synthesis attribute, synthesized attribute. Okay, but whereas in is for in value, L dot in value, we got a value from the sibling, that is the sibling is T. So we can say that it is a inherited attribute. Okay, this is a inherited attribute. Okay, because we got a value from the sibling. So now I got the value for L dot n is equal to int here. Okay, so here this is a top-down approach. So here we have got the value for L dot in here. So now I'm expanding my L node by using the productions, that is I can have this L can give L comma ID, right? So I am giving L gives L comma ID. Okay, so here again I am taking L gives, so this is L comma, again there is a ID. Okay, so for ID I am directly taking the identifier from the input string. That is why I am directly taking C here. Okay, so here again Again I have using this particular production, that is L gives L1 comma ID. L1 means it is simply the L itself. So just to differentiate, it has to know whether it is a left hand side L or the right hand side. I would just give an L1. So actually it is the same L. Okay. So here I am having L dot in. So L is having an inherited attribute. So how I can get the value? So L1 dot in means this is the left hand side L, right? So this is equal to, we can get from the right hand side, that is from the parent node. Okay. So here for this particular node L dot in, I can get from the parent node. So from this node, I can get the value to this node. So here this L dot in will get the value as int from this parent node. Okay, so here L dot in is equal to int. This value we got it from the parent node, that is here, by using this semantic action. Okay, so from here we come to know that this L1 is the left hand side L and this L is the right hand side. So here this is the parent and this is the child. Okay, so here L. Okay, I hope it is clear. Okay, so again there is a L, right? So in order to L, we can have the other production, that is L, we can take the directly, we can take the identifier. So I have taken the identifier, that is A. Okay, so next this is the production, and comma production was there, right? So here we have L1 comma ID. So I have taken the comma, again there is a ID that I have taken directly uh, um, from my input string. So finally the leaf node will be having our input string, that is int A comma int C. Okay, so we have constructed the annotated parse tree for the given input string by using which type of attribute? Inherited type of attribute. Okay, inherited attribute. Okay, so this is how we are writing the STD by using inherited attribute. So inherited attribute will get the values from, either it can take the value from the parent node or it can take the value from the siblings that appears at the left side of the productions. Okay, okay, that is about the inherited attribute. Okay, so when okay, we have a, okay, so one more point to add, that is if a grammar, if we have a grammar that is L or parsable, then we can say it is having a S attributes. There are two types of, two categories of attributes are there, that is S attributes and L attributes. So S attributes means that type of attributes will be having only synthesized attributes. Okay, synthesized attributes does not have any restrictions and all, but whereas in L attributes, it can have synthesized as well as a this thing inherited also can be there, and in inherited there is a constraint that has to be satisfied, that is it can take only that the left side symbol should be taken, right? So that rule should be considered for L attribute. Okay, so here we can say that if a grammar is LL parsable, then it can have a L attribute. Okay, so that is a point that has to be added. Okay, thank you.